In this tutorial, we are going to review some practice questions on vectors. Okay, so what do we know about vectors? So we know that a vector is basically a magnitude that comes with a direction. Direction may be given in three different ways. It may be given using the compass, the xy plane, or using angles. Then we also know that the x component of a vector is given as a vector multiplied by cosine the angle. And the y component is also given as a vector multiplied by sine the theta. Okay, where theta or our angle is given in respect or measured in respect to the positive x-axis, as we'll see in the question. Alright, so a car started from rest and moved the following successive distances: 125 meters to the north, 108 meters at 60 degrees south of west, 150 meters north of east, 100 meters to the south. Finally, displacement t. Given that the resultant of a car is in the x-axis, find the y component of vector d. So each time you're given a question on vectors, it's very important that you get to resolve the given vectors into their x and the y components. Okay, that is the easiest way to work it out. Right, so let's come up with a table showing the x and the y components of these given vectors in this case. So since we've not been given names, I'll number them. Okay, so that will be for headings. Then we have vector 1, vector 2, vector 3, vector 4. Okay, so I'll start filling in the table there. So there we'll put our vectors, there I'll put our x components, there I'll put our y components. So I'll start with the first vector there. What does it say? A car started from rest and moved the following distances: 125 meters to the north. So if you come up with your compass here, if you say 125 meters to the north, it's that side, right? That's your north, which is the y-axis, implying that there's no displacement along the positive x-axis. The angle is 90. If you want, you can use your formulas where we're saying the vector itself, which in this case is 125, cosine 90 for your x component, which is a 0. Then for your y component, 125 sine 90, which is just 125. Okay, so you can even just indicate that without even doing your calculations, because you know it is along the north, which is basically tells us along the positive y-axis. Okay, going to the second vector, 108 meters at 60 degrees south of west. So you understand this is your south, that is your west. So south of west, you're at west, because if you say of west, it implies you're at west. So of west, so you're going to heading towards the south of west. So you're heading towards south of west. So you're moving from the west towards the south at an angle of 60 degrees. So we said our angle theta is supposed to be measured in respect to the positive x-axis, implying that you're supposed to measure from that side all the way up to a point where the vector is. So this is 60. Ending at that point is 180. So for you to get this full angle, it's 180 plus 60, which gives us an angle of 240. So you're using angle 240 there to resolve vectors into the x and the y components. So we have 108 cosine 240 giving a negative 54. For the y, 108 sine 240 giving a negative 93.5. Then adding to the third one, what is our third vector there? It says 150 meters north. 150 meters. Okay, so go to that. $150 meters north of east. So it's 150. So this is your north, that is your east. So north of east, so at east, you're heading towards the north, implying that you're moving what? in this direction. So whenever there is no angle attached to it, basically what you need to understand is what you have is an angle 45. It may be in any component, it may be in any quadrant. They tell you, for example, south, or let me, yeah, south of west, for example. That would imply that is a 45. So if you're in that quadrant, using that angle would require you to add the 180 plus the 45. But since you're in the first quadrant, the angle is already being measured in respect to the positive x-axis. We'll just use the 45 there, and then we'll say 150 cos 45 for our x component, giving us a 106.07. For the y as well, we are the same, 106, since it's a 45, 106.07. Heading over to our fourth vector there, what do we have? Number 4. 100 meters to the south. So that's direct, 100 meters to the south. 100 meters to the south. So south, that is the negative y-axis, implying that we only moved in the y. So that is a negative what? We have a negative 100. There was no displacement in the x-axis. Okay, so we've indicated our first 4 vectors. Then finally, a displacement d. So we have displacement d, that is our vector d. Then given that the resultant of a car is in the x-axis, so resultant is in the x-axis. So if it is along the x-axis, either the negative or the positive, what it implies is that our y is equal to 0. So we don't have any displacement in there or any resultant in the y. It's only x. So then the question is very simple. Find the y component of vector d. So all you have to do is add all these components and equate them to 0. So you add a variable there to represent or denote your what? To denote your d there. Okay. So what do we have? So we have 125 plus negative 93.5 plus 106.07 plus negative 100 plus x should be equal to 0. So grab your calculator there, 125 minus 93.5 plus 106.07 plus negative 100. Okay. So what I have is a 37.57 plus x is equal to 0. So the value that we are finding for our x component there is negative 37.57, right? That is our value of our x component that we have for vector what? For vector d. Okay. So now in this case, the interesting part is, so of course I wasn't supposed to use y there, but it's fine. No harm to that. So that is our value of the y component of our vector d. So whatever may be the value of your x component there, would basically gets to determine the resultant of, would basically be the determinant of the resultant of your vector there. Okay. So what you need to expect is, your resultant is going to be, you need to add all these in the x. So 0 plus negative 54 plus 106.07 plus 0. So I'm getting a 52.07 plus x. So x becomes the determinant of our resultant there. Because if you look at your resultant is of course going to be given as the root of the x component and the y component. So the y component is 0, the x component is 52.07 plus x squared. So all those are going to be cancelled out because they are inverses of each one another. So you only have 52.07 plus x. So that becomes the determining values. Those are the determining values of what? This is your determining value of your resultant. It should just be along what? It should just be along the x-axis. So you'd want to avoid cases where it is equal to 0. So it should not be you don't want your x value to be equal to negative 52.07. So if you look at what you would want to expect more, you'd want to expect more of your x component of your d, in this case, to be a value that is somewhere between, let me say, negative 52.07 going this side. Okay, of course, knowing that it's y component, or it's y component that you're from calculating is what. So that was 37 point something, negative 37 point something. Okay, so basically that is what your range of values that you expect for your x there. So we've already answered that question. I was just trying to give you more information and more understanding on this question. So let's head over to some more questions that we have. Given that vector A has an x component which is twice the y component, the magnitude of vector A is 25, what is the x and the y component of vector A? It's a very simple question. So we're given that vector A has, so a vector A has an x component which is twice, so given that vector A has an x component which is twice a y component, so vector A, so we have a vector A, then we have its x and then its y component, right? Interesting. So we are told, given that vector A has an x component which is twice the x, the y component, twice the y component. So it's like if you are insert a certain variable to denote your variable y, I'll use values other than x and y. I can use maybe letter L, for example. Let's say L is denoting our y component. So x component is twice the y component, so it's going to be 2L. Okay, then we are also told the magnitude of a vector is 25. What is the x and y component of vector A? So we do understand that the magnitude is given as x squared plus y squared is equal to the magnitude. Okay, so the magnitude squared, that is the formula. So if you get to look at your magnitude, it's supposed to be the root of that. So we've been given the magnitude already, 25. So I can square both sides, so that we have 25 squared. Okay, so our x is what? 2L squared. Our y is what? Is L squared. Okay, so we've come up with a relationship there, just understanding the information that we have. So 25 squared is what? 625. 2L squared is what? So that is 4. Then you have L squared. So you have 5L squared. 625 divided by 5 is 125. What is the root of 125? 11. So L, 11.18 meters, right? So remember L, this was denoting the what? The y component. So you said our x, y, that is was L, this one was double, twice the y component. So your y component is 11.18, then your x component is twice what? 11.18. Okay, so this is your x or your y, then your x is double that, giving us 22.36, right? Now you would want to prove your solutions by squaring that, by squaring both of them, okay, and then finding the square root to see if you're going to have the same solution, which is basically true. So these are your x and y components of your vector. Given that vector A and B are in the same direction, and A minus B, so we have A minus B is equal to C. Vector A is only a quarter of vector B. So vector A is only a quarter. So a quarter is 1/4. Is only a quarter of vector B. Okay, cool. Then what else have we been taught? The x component of vector C. So the x component of vector C is -4. So I'll say my Cx is equal to -4. My y component is 2. Find the x and the y components of vector A. Very interesting, right? So what should we do there? First, to simplify our work. So we are interested more in A, right? And we've been given our C. And we've been given the overall equation there. So in that equation, I don't want my B to appear. I would want to replace it by A. So if I look at this equation, I can make B to be the subject so that I replace it with 4. So I can multiply both sides by 4 by 4. So my B is going to be equal to 4A, right? So going back to that top equation, where there is A, it remains A. Where there is B, we have 4A equal to C, right? So the equation has reduced. A minus 4A is -3A, being equal to C. And since these are in the same direction, I can use the same equation to find the x component and the y components respectively. So for my x, for my C, I know it is -4. So -3A is equal to -4. So my x component of A is going to be 4/3. I can go to the other part. So I have -3A is equal to my C, my y component is 2. So in this case, since one is positive, one is negative, my y component is just going to be a -2/3. So I've found the x and the y components of vector A by using the relationship that was given in the question. Question 4. A toy car started from the origin and moved the following successive distances: 1 meter to the east, 0.5 meters to the south, 0.8 meters west of south, and finally 0.4 meters to the west. Find the resultant of the toy car and the direction. These are simple questions. So 1 meter east, that's our first vector. So coming up with a table showing the x and the y components of the vectors that we have. Let's see what we have. So for our first vector there, I'll indicate vector 1. We've been told 1 meter to the east. So draw your compass here. 1 meter to the east. So east is towards the positive x direction, right? So that one is direct. You have 1 meter. For the y, it's 0. If you want, you can try out. The angle there is 0. So you can say 1 cos 0, 1 sine 0. This is for your y, that is for your x. You find the same answers here. Then 0.5 meters to the south. To the south, it's direct as well. That is just along the negative y axis, right? Telling us it's negative 0.5. There's nothing in there. There's nothing in the x direction. The third one, 0.8 meters west of south. West of south. Of what? Of south. So south, it means you're at the bottom there. Now you're heading what? You're at the south. Now you're heading towards what? West of south. West. So you're heading this direction. West of south. You're at the south, heading towards the west. Something like that. Okay. Have we been given any angle? No. So we'll use the 45. We'll split that into 45. That quadrant into 45, which we can show better now. Okay, so 45. So 45. So this is 45. 45. So 0.8 meters west of south. So we want to measure our angles in respect to what? In respect to our positive x-axis. Okay. So if you measure this way up to that point, so that would be 180 plus the 45, 225. Then want to find the x and the y components using the 0.8. So for x component is going to be 0.8 cos 225. So 0.8 cos 225. So negative 0.566. For y, 0.8 sine 225, which is also negative 0.566. Okay, so that is for our third one. And finally, 0.4 meters to the west. So the west is to the negative side. So that is negative 0.4. In the y, there's nothing. Okay. So now the question says, find the resultant vector and the direction. So for resultant, we need to do summation of the x and the y components respectively. Okay. So let's get to do that. So that is our resultant. We have our x, and then we have our y components, right? Okay, look at the information that we have. So for your x, you would want to add up everything on the x part. So we have 1 plus negative 0.566 minus 0.4. So what we have is a positive 0.034. For the y, we have negative 0.5 minus 0.566. Okay, so ultimately result is negative 5.566, right? So we have the x and our y components for our resultant vector. So we can use that to come up with our magnitude and also come up with our direction. So square your x and square your y. Squared, that is also squared, then the root of that. So 0.034 squared plus negative 5.5, so 5.566 squared, root of that. Okay, so the answer I'm getting is 5 points. 5 points. Okay, so why did it? How does the y component even come about? Let's review our calculations. Let's review our y component. So 0 plus negative 0.5. So negative 0.5 plus negative 0.566. So it was supposed to be negative 1.066 for our x. 1 minus 0.5, so 1 minus 0.566 minus 0.4. Okay, so for the x it's okay. For the y, we have that. So square was, make sure you show the brackets so that your calculations are okay. So that squared plus negative 1.0 negative 1.066 squared. Okay, then the root of that. So 0.034 plus okay, I'm getting a 1.08 meters. So what is your resultant there? In your direction, even when they don't state in the question, when they ask you to find the resultant vector, make sure you also find the direction. So your x component is 0.034. Your y component is a negative, right? So you expect it to be in this between, that is like 270 and what? 360. Okay, so whenever you have a negative, ignore the negative to make things easier. So tan inverse y over x, ignoring the negative. So 1.066 divided by 0.034. Then tan inverse of it. So my answer is 88.17 degrees. Now that is a reference angle because we ignored the negative. So the actual angle is supposed to be in the fourth quadrant, so we need to subtract from 360. Right? So our answer is 271.8 degrees. That is our angle there. So whenever you are presenting your solution, you'd want to make sure that you show, you say it's 1.08 meters, 271.8 degrees. So that is your vector and the direction. So thank you very much for taking time to watch the video. I just hope that you now have some basic concepts reviewed under your vectors in your physics study.